Well,
Hey, how's it going?
hey, going pretty good with yourself?
Pretty good. This is my first one of these, so pretty excited.
Okay, well then let's just dive on right in.
Yeah,
I think I'm going to ask you an algorithmic question, if that's all right.
sure.
Um, so there's a little selector box on the top right of the coder pad. It says plain text now,
Yep.
and you can pick any language that you think makes sense for an algorithmic type question,
Yep.
whatever you're comfortable with.
I'll probably
Um,
do Python.
Python, okay, those are usually pretty good for these things. Um, okay, so we're going to start with a basic problem, and we're going to kind of add to it. So the first one is pretty simple, and the idea is you're going to define a function that takes in two strings and returns whether they are equal with respect to in a case insensitive way. So of course Python actually does have this, but we're gonna work through a couple additions to this once we get the basic one down.
Okay. Cool. So, um, I mean, there are other Python built-ins that could make this pretty easy as well, like turning the string to lowercase or uppercase,
Yeah,
and then
yeah.
comparing
No,
it.
so you can use any of those.
Okay.
Just and then we'll talk about the implications of using those and all that kind of stuff.
Okay, so that would look something like this. Um, and I think that that would do it. I'm assuming by case insensitive you just mean like uh, uh, basically letters of the alphabet.
Yeah. Mm-hmm.
Um,
Okay, so let's just for fun write the in the shell
sure.
case insensitive compare of ABC and capital ABC. See if that
Yeah.
works.
Okay. Oops. Oh.
I think
Oh,
you'll probably want to do it just in line here,
oh, got it. I see.
and then you'll say run.
Yeah. I see. Yep. Oops. Oh shoot.
Okay, excellent. Um, so what is the time and space complexity of this algorithm as you have implemented it?
Well, I don't know how upper exactly works under the hood, but I'm guessing what it does is uh, it likely builds a new string, character by character.
Mhm.
So that would suggest that you have a linear running time, and memory is also linear.
Okay. Yeah, as far as I know, strings in Python are immutable. So if you call something like upper, then it's going to have to return a
A
new
new
string.
string. Yeah, exactly.
Okay. So, and that's the best case, worst case, average case, always case.
Uh, Memory is going to be always case. Yeah, I think running time would also be always case unless there's something I'm missing.
Okay. No, that
Yeah.
makes sense. So let's say that these are very long strings and we don't expect this to happen very often. Is there an optimization we can make to this so that in the best case, it doesn't take O of n time?
Sure. So not expecting it to happen very often, you mean that like
That
uh
they're equal. So we're expecting that most of the time
most of the time
strings are not actually going to be equal.
Mostly they're not equal. Oh, okay. Interesting. Yeah. So we could do something like okay, I'll talk about it first. So we can go well, first you'll want to check the lengths of both of them and see that the lengths are the same.
Sure.
And if not, you can loop through both of them simultaneously, and do a comparison character by character, and compare them that way.
Okay. So let's.
Yeah.
Sounds good.
So. And actually, I guess we don't really need this. Yeah. Actually, wait. Trying to find the cleanest way to do this.
Okay.
Oh wait, wouldn't want to create a new one.
Wait, create a new what?
I wouldn't want to create a new. I guess this might terminate early, so this might end up being. Okay, let's do it this way. This way for now.
Okay.
And just to make sure that. Okay, interesting. Oh, right, of course.
I think we should probably have one not one failing case too. So like ABC with DEF or something.
Yeah.
Just to make sure. Okay. Excellent. Quick question here. I don't know, this is kind of an extra credit, but as you've written it, these are, I guess it depends on which Python we're using. If these are Unicode strings or 8-bit strings. But if this is Python 2,
which it is.
Which is? Do we know? You guess?
I think it's somewhere.
Python. Oh yeah, Python 2.7.
Yep.
Can we think of any possible thing that might go wrong with this?
Yeah, I mean, we could compare. You could be comparing Unicode versus 8-bit strings here, and I imagine that might cause problems.
Well, let's even just think in terms of just both 8-bit strings, for example.
Okay. So ways in which this algorithm.
You don't necessarily have to fix this problem because the 8-bit string thing is kind of a mess.
Yeah.
So I'm just curious how familiar you are with what, like, if this was like, if I can, like, if it was ABC and oops, that's not the one I wanted. ABC.
Yeah.
So let's even see if that works.
Yeah, curious.
Oh, it doesn't.
It doesn't.
Which is okay. Can you think about why this isn't working?
So I don't know how the upper conversion happens behind the scenes, but I'm guessing it either ignores. Actually, one thing I'm curious about is what that actually is for these strings. So it doesn't get converted. So it probably has some white list of characters that it only works on.
So interestingly, what you'll notice is that Python is pretty good about this if you're dealing with. Oh no, it doesn't even work. Huh, that's interesting.
So if we did
I would have guessed that would have actually worked, but
oh really? Maybe in Python 3 that works. Yeah. But let's see what happens here. Oh.
Wow. Huh. Oh well. In any event, that's funny. I actually would have thought that calling them Unicode strings would have fixed your problem, but maybe not. In any event, let's not worry about that case for now. That was just kind of an extra credit one.
Yeah, interesting.
But okay, so that's all good. Now, what is the best and worst case, like runtime and space complexity of this one?
Well, best case is that the first character is different, so that would be O of 1. Worst case is still O of n. So average case depends on what your input looks like, but right. Yeah. Memory is memory is the same as that, yeah, because it's also memory is best O of 1 and at worst O of n.
Is it O of n at the worst case?
I believe so, because you'd have to create a new copy of each character because I'm using upper here.
But is it going to keep those characters around? Like, do you need all n of those?
That's a great point. No, it's not going to use those over and over again. Or sorry, yeah, it's not going to create new ones each time and keep all of them around. So yeah, it's I believe it would be O of 1 then.
O of 1. Okay, excellent. So already we're improving on it. That's good. Now we're going to introduce a bit of a wrinkle, and that is, what if I want these to return true if they're the same, or their edit distance is 1 or less? So are you familiar with edit distance?
I am, yeah.
Okay, good. So in that case, for example, like we've shown here, like this is going to be true, and this is going to be false, and this is now actually going to be true. I guess we don't really need that anymore.
So we want right.
So in the case that I wrote, there was an insertion of a D.
Yep.
And you could also imagine that that a deletion would also.
Correct. Yeah. Yeah. Let me think about that.
And there's definitely a number of ways of doing this. So whichever way you want to think about starting it is totally
Sure.
fine.
Yeah. So I'm thinking about whether I can still use this kind of like iterate through each string, but I'm wondering if that's constraining my thinking.
Mm-hmm.
So basically what we can tolerate is one insertion or one deletion or one modified character.
I mean, we can define that any way we want, and I think actually it makes things a little bit more straightforward if let's just say insertions and deletions.
Oh, I see. Okay.
Just to get started.
Oh, okay. All right. Interesting. Okay. So then there's the So there's an algorithmic approach then where you that would just be a simple modification of well, maybe not as simple, but basically a modification of this algorithm where you keep track of both iterators and you iterate them together, and if one of them is off, or if one of them has a mismatch, basically you iterate the next one to see if it is an insertion or a deletion, basically. And actually, the action you would take would be different if if it is truly an insertion or a deletion. So let me think about that a second. But the approach I'm thinking of involves still using that approach, the two iterators.
Okay.
So, and if you had, let's see, you could, sorry, give me 1 second to sort of work this out.
Take your time. Take time.
Okay. So I'm thinking now that I might use this method I've written as a subroutine.
Okay.
So the actual so that this might be then this would call basically this new instdel compare would basically call out to the case sensitive compare.
Okay.
And okay, so haven't fully thought this out yet, but let's see what happens. So I so if the lengths are not equal, then we check if they're within if they're within one of each other, I
Okay.
guess. At this point, we at this point we hypothesize that the longer one has an insertion relative to the shorter one.
Okay.
Yeah. Okay. So, I just realized that this problem is symmetric in that way. Okay. Then for actually, maybe we don't need to. I see. This will end up being a modification of the first method. So let's see. Oops.
Yeah, I see what's
Maybe, yeah, I'm just sorry, I'm working out like the fence post issue I have here.
okay.
Uh, oh, I see. Okay. Oh, sorry. Dot upper. let's see. At this point we push the longer one more. So yeah. If those two aren't equal, or rather, actually, yeah, okay. Ah,
I could see a case here where I guess if you've already checked that the two are only one apart.
mm-hmm.
I'm trying to think.
Whoops.
I guess there's no way to. I was thinking with this loop, the longer one could just have have twice as many characters as the first one. But you've already checked that the lengths.
They're off by one.
Right.
I'm not sure if I'm done or not. I think there's like something I'm missing that I need to see the case to
Right. Well, I mean, so first of all,
wrong.
like if the lengths are equal.
Yeah. Okay.
I think there might be something else going on here.
Yep. Yeah, you're right. So let's see. If okay, I'll be lazy.
I mean, that's just the else statement of the previous one, right?
Right. Yep. That's right. Oops. Sorry.
Yeah, that makes sense. I think if I wanted to return that.
Yep, I would.
Mm-hmm. What about the else of the previous if statement, the one on 15?
Right. Then they would just be
Yep. Yeah. Okay. It's looking good. Okay. Well, let's run it. Right. This part here,
sure.
It makes me like a tiny bit uncomfortable because it doesn't. It seems like you could do this multiple times, but I think actually because you're doing the check up here, then that's stopping it from actually being able to go multiple times. But
what do you mean by the whole thing could run multiple times?
Yeah, like this whole for loop could go multiple times where like this doesn't equal that, so then you push this one, you increment that one,
yes,
and then
I see.
it's going. But I think actually because of the way you've written this check up at line 15, you can't do it any more than once. And as you noticed, there's that symmetry to it.
Yeah.
This would hit either an insert or delete by checking out the shorter one. So yeah, let's see if this works.
All right.
I think it should. Unless
I'm not sure either.
Right, that's right. All right.
Works on these cases.
Can you try that? Yeah, on those two as well. Look at that. Okay, very good, very good.
That's pretty cool. Yeah.
And then what's the runtime complexity and space of all of this?
Okay. In the case, obviously, in the case where the strings are equal, it's the same as before. If in the case where they're not equal by one, or if they're in the case where they're not equal by one, yeah. Runtime would look like also it would also be between O of 1 and O of n. And in the case where, yeah, I guess memory is the same as before too. Memory would be O of 1.
Yep.
For the
Okay.
same reasons.
Excellent. And now the really tough one.
Oh
So
dear.
this is great. It's all correct so far. And now I want to add a parameter that says, instead of it just being hard-coded to 1, what if I put a parameter at the end here for how many
edit distance, or how many
distance I'm willing to
tolerate.
So if I did like 2 here, then that would still be true.
Okay.
Yeah, the last one, there's 2 deletes instead of just the 1.
Okay. Yeah, I mean this is pretty hard because you could also have what shows the case more clearly?
Yeah, so one could be a delete and the other one could be an insert. So
yeah, exactly. Yeah. So yeah.
Yeah, exactly. So you were able to take a nice little shortcut by checking the length up here, because you took advantage of the fact that with only one edit, then the lengths are telling you something, whereas here the lengths aren't telling you quite as much because
Correct.
Like you've shown in this last one, they could be the same length, but depending on what that number is, it's either acceptable or not acceptable.
Right. So still thinking of I think I'll have to change my approach a little bit.
Okay.
So
Sorry if you can hear my dog barking in the background.
Oh, no worries. So unfortunately, I actually have to head out in about 5 minutes. So maybe what I can do is talk about what I would do.
Okay.
And a few approaches.
That's fine. Yep.
Yeah. Sorry about that. Didn't realize it would go for this long, but this is fun.
No problem.
What I'm thinking is, one kind of cheapo way is to actually implement the Levenstein distance and kind of compare it that way. That would
Okay.
that's a pretty standard kind of dynamic programming type of exercise.
Yeah. And do you
Um,
know the space and time complexity of that?
oh shoot, let me think about it. I'm thinking space would be up to n. No, space should be space is n, I believe, because you're keeping track of a parallel array essentially, unless it's n squared. If if you have to keep track of like every pair of characters, which
Yeah, the standard approach, you build up a table that's n by n,
yeah,
it's n squared,
I'm
but
thinking about that
there's
n squared. Yeah, go
yeah, so
ahead.
it's n squared, but then there's this one optimization you can make that you never actually look more than one row behind as you're filling in the table. So there's this optimization that you can do it in O of n, but
I
it's
see. Yeah, okay. I can see how that optimization would work. Yeah.
yeah.
Um, so yeah, that would be one way that I would do it.
Yeah.
It would
And
take
that's
me longer than 10 minutes to implement,
yeah,
unfortunately.
yeah, no, that's
Yeah.
fine. That's fine.
Um,
So then, yeah, so
yeah.
we're looking at O of n space, and then what's the time complexity of that approach with just like getting the full Levenshtein distance?
Yeah, time complexity I think is O of n because you uh yeah, you're basically filling out this table in each step of uh uh
So,
each cell of the table. Basically you're only looking you're not like looping through the entire like backlog basically. So
but how big is the table? How many cells?
table is n. Or
So it's got one. The table has all
it's
the characters on the first one as the rows, and then all the characters as the second one in the columns.
right, correct. Is the smaller table you build, it's the size of the diagonal of that array, I believe. Is that correct? Or
So it's an n squared table. So because you have
correct.
all the characters on the top, and then the optimization is what you're saving, but you still have to fill in every
Oh, okay. Got it.
cell in the table.
Oh, okay. I see.
So then,
Um,
yeah, so that's a good base is like O of n squared time and O of n um,
memory.
memory.
Yep.
But then the question is there a way to improve that? And obviously, in the worst case, like if the tolerance were the number of like letters, and you still had to fill in that whole table, then even like the worst case in any implementation is also going to be out that far. But sort of what we're trying to do here with the going incrementally through and shortcutting it is trying to see if we can find a way to stop it early, so that in the best case we're not filling in that entire table. We're making
You'd terminate early somewhere.
right.
Okay, that's interesting. Maybe I'll try to see if I can get that working after this. That would be cool.
Yeah. So another thing, just to throw it out there,
Yeah.
so I have to go, is if you take a look at this tolerance, you can think of so you need to get rid of the this piece here with the lengths, because you can't do anything with the lengths.
For sure, yeah.
But you can take a look at this step here, where you can think of the problem as being if the two characters that you're looking at are not the same, one of two things could be happening. It could be a deletion, in which case you've sort of used up one of your tolerance, and then you're just repeating the same problem for the substrings afterwards.
Yes.
Or an insertion, and then you're doing the same thing. So you basically call.
I see.
So and with the iterators, I'm not sure. Not sure if you could make that work with the iterators instead of just using like indexes into the string, but it would basically be that you would call instead compare twice on the two possible, like was it an insertion or was it deletion with the tolerance like minus minus kind of thing.
Yeah, and you would basically return the or of those two.
Right.
Okay.
Yeah. So just something to think about if you have time and want to work through that.
Yeah, cool. Thanks so much. That was a lot of fun.
All right. Well, take care and good luck with all your interviewing.
Thanks. You as well.
All right.
All right.
Bye.
Have a good one. Bye-bye.